let's start. This is the UI of Millbox application. It's very user-friendly and easy to use and to learn. On the left side, the job management and nesting tools, and you have also the button of undo and redo. On the right side, you have the workflow toolbar, and you have the import, material selection, calculation, and simulation. In this area, you have the information about the job, like the job name, project name, machine, material. Here you have a configuration and setting button. First time you start the software, you may need to change the languages. Usually, Millbox will use the same language of your operating system, but in some cases you need to modify manually. Here there is a list of available languages, and this can help you to have one familiar environment. Now let's see together one simple case in Millbox. First step, we click on new job. Then we have the list of machines. In this case we click on AMD-500, and this is the tools package. We can see the position of each tool. We have 3 ball tools and 1 flat. Then we select the material, zirconia, PMMA or wax. In this case we use zirconia. Then we click on the fixture, that is a C-clamp. Then confirm. This is the import step, where we can select STL files in this area. We have the STL types. Then we have the preview window. It is very important to combine the correct STL type to the file. Then import, and this is the multiple import process. Then we select in the meantime another file, combine the right station type, then import and go to next. This is the step of blank selection, but now we can see that when Millbox imports the objects, automatically detect the margin lines, undercuts, and insert directions. On the right column, we have a list of zirconia materials, and we have Aidite zirconia libraries. For example, Aidite 3D Pro, we have this different disk size, and here we have the minimum thickness required to mill those imported STL files. With this button you can create a new stock, and then with this one you open one existing stock. Then we create a new one. We input scale factor, the screen gauge. Then we add the name for this blank, the code. Those information are very important to search this blank in the future. Apply. Then automatically Millbox will nest and create the pins. With the view tools on the left top side of the screen, you can change the view. Also, you can use hotkeys to change the view. Then with the mouse wheel, you can zoom in, zoom out. The rotation is using the mouse right button. Then pen is use the mouse middle button. It is very easy to move, to rotate, and to do panning. And also in Millbox there is a very smart function. The holder can automatically change the colors and become transparent. This allows you easily to do the nesting. Also, the other features like margin, undercuts, and orientation are all detected automatically. Then with the mouse left button, you can select one object, drag and drop to move. Click on the rotation axis arrow to rotate and adjust the position. And this can help you to manually nest your objects. We see again the auto transparency function of the holder, and we see the multi-layer color effect that is very important when you use Aidite 3D Pro materials. Then you use Ctrl+E to hide or to show the holder. You can use the axis movement to adjust the height, then to rotate X and Y orientation, and this helps you to make the right color match. Also on the screen you can see the angle in X and Y. If you make some mistake, you can do undo with this button. When you click on the pin, appears equator line. This line can help you to place all the pins in the right position. And using the Ctrl plus mouse left button, you can select more pins for multi-selection. Then you change the diameters. And from one cylinder pin, you can have one conical pin. Of course, you can change the pin type from not cut to cut or to semi-cut. You can select one pin, then do drag and drop to move the pin. And you see when we move the position near the equator line, we will reduce the undercut. Also, you can change the pin orientation using using the mouse left button. You see, it is very easy to place the pin and change the position. Now we control all the position and make little change, and then we change the view and we see the difference on the two objects. Also here we change a little bit the position. Now also we can directly move the pins from the top view. It is very easy. Then we see how to add and remove pins. Just put the right parameters. Select the pin type, cut, for example cut, then click to create the pin. Now you see the different color. Then To remove, it is very easy. You select the pin, delete, or use the keyboard delete key. Now we see again one detail of the equator line and the undercut color. You see when you move the pin appears one gray area, that is undercut. That show you be careful and you need to put in the right position. Okay, that is very user friendly. Right, now it is ready. Last check before calculation. Then we start mill, clicking this button, then serve the toolpath. This is the window of milling options. Depending on the machine and on the restoration type, you have different options. Now you can use 3+2 automatic external undercut strategy. Here we have the tools, 3 tools from 2 mm to 0.6 mm for anatomic details. When Millbox finishes the calculation, we have the NC file saved in this folder. Also, you can go in Tools, Toolpath to open the folder. The NC file has the same name of the project. That's all for this simple case. Now we start to see one anatomic implant bridge demonstration. First step, the same, we select the machine, the material zirconia, the holder, and confirm. Now we select the STL file. Then we select the restoration type. It is important to select the right one, the anatomic abutment bridge. Then import. And during the import process, Millbox will recognize implant interfaces, screw channel, undercuts, and the orientation. And the dark gray area is for undercut. You have the different colors to represent the different part of the STL file. Now we create a new blank based on the thickness suggested by Millbox, and we input the blank name, scale factor, the lot code, confirm. Here we see the multi-layer zirconia color representation, the different color in the incisor and margin area, and we use Ctrl+E to hide the holder. And we see all the undercuts, the screw channel orientation, screw channel axis. And now we click in tools, then stabilizer, and because the material is zirconia, and we need to create one stabilizer. Inside the Millbox we have now 5 types, and depending on the different design we can select the different one. And you see it's very easy to put the stabilizer, and it is also possible to edit the size, change the type, just clicking on the STL. Then when you decide the right one, just click on confirm. And now we start the nesting using the mouse. Also you can use move and rotate arrows to adjust the position. Then when we find the right position, we start to create pins. It's very easy. Just click where we want to create the pins. Now also in this area there is a smart function. You see, when we rotate, the stabilizer will automatically become transparent where needed. Also the color representation inside Millbox, it's very useful. You see where you have the undercut, the equator line position. All these tools help us to the right pin placement. As you can see, the pin creation has no limit. You can create the pin from different view, from different angulation, and the Millbox algorithm can create the pin in the right position for you. Now let's create the pin in the opposite side. The equator line and gray area of undercuts can help you to put the pins, and also you can use the right button of the mouse to rotate, and the middle button of the mouse to pan, or also the mouse wheel to zoom in and zoom out to make the screen bigger. And also you see when you create a new pin, appears one great area. That means you create an undercut. So pay attention when you put the pins. And here I show you one example. Okay, I create one pin, also a second pin, and the third pin. You see that in the second pin there is a big area of undercut. So we click, select the pin, drag it lower, and also in this. And now we remove the one undercut area. When we finish the pin positioning, we do the last check. Depending on the material and also on the design of the restoration, we need to use different type of pins, different size, cylinder or conical. And when we have all defined, we click to save the toolpath. And that's all. It's very easy. Now we see other function in Millbox. This one is job management. We can see the previous projects. We have one preview screen. Then we can double click to open one. That is very easy to help us to manage all the projects. When you want to check the software version and your dongle number, you can go here in support. Then you see your dongle number, your license number, the activated modules. Then also here you can create the file for support and the TeamViewer ID for remote control. Another important thing that I want to show you is the curve creation. Go inside tools, curves and surfaces, and here you have a lot of tools. Okay, but today now we see this one, delete curves and the cylinder caps. This tool is very useful when you need to recreate the margin line. This button is for automatic margin line creation. Just click on the STL and Millbox will create a new margin line for you. It is very smart way and easy way. And now we delete again the curve, and I show you the manual draw margin line function. Now with the mouse we draw by hand a new line. We need to be precise, and then when we finish we'll create a new margin line. This tool is very useful, especially for not standard design, and provide us more freedom and allow us to create more customization. You can check the imported STL type by clicking on it. You see here the STL type, and now we can change it from copying to anatomic crown. Of course, it is very important when you import the file to select the right type. The meaning of offset value here. You can see the difference between 3 and 3.5. The space between the material and the tool changes. And this is very important when you mill big cases, and bigger space can allow to reach undercuts. Here we enter in the configurations where we have several options. For example, first one is the languages, and we have this long list of available languages. Second tab is about stabilizer, and here we have the standard settings, then divided for zirconia and other materials. And here we can select as default one type, or we can change the parameters like thickness, height, and offset value. And then at the bottom we have some customized options. Next tab is for cavity fit, and here we can create some presets, and it is divided for material and object type. So for each material you can select different object type, crown for crown and for other type. Then for each of them you can select and edit values, so you can customize this option. The next one is supports, and here we can create our pin profiles, and you can assign as default uncutted supports or semi-cut, and also you can create your own settings divided for object type, like crown, full crown, bridges. So for each of them you can use different pins creation algorithm. For example, create no pins, or use our algorithm to put the pins near the equator line, or put the pins on equator curves. So we have different options. Then for each type we can divide it in material. So for each material, for each object, we can assign different pin parameters, different diameters, and with this button we can apply to all materials, and the other one is to apply all objects type. So it's fully and highly customizable, and you can create your own system. This is multi-selection function, and we can select more STL files, use the mouse, or using keyboard key shift plus mouse left click, and we can select this group, then define the type and import all them in one time. Now we see the Millbox behavior when we do the multi-elements nesting, and in this case we do the automatic nesting. And the first one, after imported all the STL files, we create the new blank, and then we click on apply, and we will see that automatically Millbox will put all STL inside the disk and creates the pins. And this pin profile is defined in the background as we saw before. Now let's see the cavity function. In the configuration tab we saw that we can set some parameters, and here we see in action. So you can select one STL, then we can adjust this fit. This is very useful when we need to make the cavity more tight or loose, because sometimes the design is not perfect, and we don't need to redesign the file. We just use this function to adjust the cavity. So you can put and we can remove more material or to keep some material. The selection function in Millbox, it is very easy. You can select object one by one with the mouse single click, and with keyboard control button you can select more than one, and you can move as a group. So you can click it all of those 4 STL files and move it together. When you select one object, we will see that appears one blue border on it, and this can help you to see if one object is selected or not. If we need to unselect, deselect is to push control button and click again. And now we see the one special function inside the Millbox, that is the thickness. It is a more CAD function, but we think that it is important also in the CAM software. When we have some doubt about the thickness of one STL file, we can click it and see if it is thick enough for milling. For example, when we click on this only, we see the border, if it is thick enough, and it is good. That's all for today's overview. Thanks for your attention, and I hope you enjoyed the video, and see you soon in the next video.